This is our paper, Typing in the Matrix. Um, this was a project we completed under our Human-Computer Interaction course, CS 449. Um, so what is augmented reality? Augmented reality is a fast developing and a popular technology for immersive interactive environments. It allows for a digital layer to be overlaid on top of reality. And thanks to this, AR can be used to create interactive environments without any cyber sickness or any spatial awareness issues for the users. Additionally, this technology allows for the ability to work on real and physical projects with the assistance of a digital source of information along with them. As this is a computer-generated reality, it requires some information input from the user. And this is usually done with hand gestures, but uh, in some cases there can be requirements for more complex methods of interaction through text input. And this is a requirement that would have to be inevitably addressed. Um, because of this, it is crucial for the development of immersive technologies to make these interaction methods as user-friendly as possible. Um, so for proficient typers, they are most familiar with physical keyboard environments that are solid to the touch and allow for a tactile feedback. And additionally, experienced users tend to use the 10-figure typing method. And due to the medium of AR, many of these familiarities are hindered or outright impossible. To explore how these aspects are affected, it's important to do user studies and explore how their typing patterns are affected to better understand and design interfaces. To this end, the major aspects to explore are the typing speeds and the gaze locations of users. In our background research, we were unable to find many studies covering this topic. One study we found was from Neimer et al., and it explored the typing performance of users in virtual reality, where they were unaware of their surroundings and their hand locations, at least how they appeared in the real world. And they concluded that there was a reduction in the speed of interaction in virtual reality. And similarly, the works of Bowman et al. Corroborated that the accuracy of users when typing physically was greater than when typing in virtual or when using speech recognition interaction methods. So we found that there was a lack of studies in AR environments, while the literature has been mainly focused in virtual reality interactions. And for this reason, we focused on the performance difference between physical and AR interactions. As a preliminary study, we decided to focus on native Turkish speakers who were already proficient in typing physically to see how they interacted with AR keyboards. We found that the standard keyboard provided by the MRTK toolkit for the most universal and replicable keyboard layouts. As this was a keyboard-to-keyboard, our users would also require minimal adjustments to to be comfortable with using this keyboard layout. And we can see how a US keyboard-to-keyboard compares with a Turkish keyboard-to-keyboard here. The top one is the augmented reality keyboard, and the bottom one is a picture of the physical keyboard that we used. As you would notice, the layouts are similar to cause minimal interference. We also have a video demonstrating the interaction with the AR version in the next slide. As you can see, the user is able to perceive their hand locations and interact with holographic UI interfaces. But due to the keyboard having these holographic button prompts, it's harder to interact with it through a expected accuracy of physical keyboards. For example, some button prompts on this interaction sometimes type double due to hand interaction issues. But the user gets used to it, and as they get more experience with the UI interface. I will skip the rest of the video. I believe that demonstrates the interaction well enough. So for our study, we recruited 5 participants, 3 men and 2 women, and they were all undergraduate university students of similar age and background. We had 5 texts from Turkish literature of similar lengths to control for the study length as much as possible. We gave each participant these texts randomly. And you can see a example text over here from a classical Turkish literature novel. So we initially asked our participants to type a random text, a randomly selected text on the physical keyboard. We tracked their eye tracking data to later evaluate their gaze locations and fixation points. To do this, we use the Tobii eye tracker. After the users completed their physical typing task, we asked them to vary the HoloLens 2. We provided them with simple tasks to get used to the HoloLens interaction scheme. And after this initial task, we provided them with a different random text and asked them to type this text on the AR keyboard. We tracked their eye tracking data through the built-in eye tracker of HoloLens 2. And finally, at the end of each task, we gave each participant a questionnaire. And additionally, we tracked the typing times of each participant. So to analyze our collected data, we use the Tobii ProLab for the data collection of the Tobii eye tracker. And we analyze the fixation points on each key of the typing environment, as well as the screen that the user looked at. The AR data collection was analyzed with the help of a Python code for similar parameters. So for the physical fixations, we saw that users mainly focused on the screen and not the individual keys. This shows that the users are proficient in typing physically, as they need to monitor their typing locations very minimally and fixate on what they have typed overall. Compared to the physical fixations, however, the AR keyboard fixations of users were more focused on the keyboard rather than the screen, but the screen fixations still dominated. Additionally, the time spent for the task in the AR section is much longer compared to the physical section, if we compare the fixation times of both graphs. This indicates that the users had more difficulty when typing in the AR environment for typing text of similar length. So in the physical typing section, the maximum average fixation of each user never exceeded 80. However, the average fixation of users in the AR section was nowhere close to their scores in the physical section. And we can see that the minimum average fixation of the AR section is higher than 500. This means that the users had to fixate on the keyboard more, and this also shows that the users had more difficulty while typing in an AR environment. And in the questionnaire, the users reported that they were not satisfied with the experiments. Additionally, the users reported that they all preferred the physical keyboard over an AR keyboard. And finally, the users reported that they would not prefer to use an AR keyboard in their daily lives. And from our study, we see that experienced users are hindered and have negative experiences with AR technologies due to the unfamiliar input interfaces. And this is a big hindrance for AR technological adoption and shows that the virtual typing environments require improvements in their user experience to achieve wider adoption. We suggest that the exploration of this area for further study. A major limitation of our study is that we were unable to conduct our research for a long-term user interactions. It's possible that after enough interactions and experience, the users will be able to type at comparable speeds with their physical environments, the counterparts. An alternative area of research can be the study of speech-to-text inputs or the use of virtual assistants for these complex tasks, or alternative keyboard layouts or keyboard interaction schemes. And finally, to study the effects of physical interfaces, users can be introduced to tangible or variable interfaces as well. For example, they can be asked to wear glove-typed interfaces to type instead of using holographic keyboards like how we used. Thank you for attending my presentation today. I'd be happy to answer any questions that you may have.
Thank you very much, Mr. Bilgehan Çağıltay, for shedding light on the ongoing evaluation of user interfaces, and your videos help us to better understand the issues with keyboards and in virtual and physical environments. I would like to ask again, does anyone have a question for Mr. Bilgehan Çağıltay? Okay, thank you again, Mr. Bilgehan Çağıltay.